In the video Basic Electricity Part 8, Introduction to Diode Theory, I discussed how diodes work and their usage. In this circuit, we are using it as a demodulator or RF detector. RF stands for radio frequency. To review that, the schematic diagram of a diode is this, and the diode itself looks like this. Notice the black band on the far end of the diode. This is the cathode marker. Now to connect the diode, we need to solder the anode, the end without the black band or marking, to the base of the transistor. The reason is because, as we stated in the diode video, the diode is a one-way device allowing current to flow from the cathode to the anode. The cathode usually connects to the signal source, in this case, the signal from the antenna. That is, the current flows from the antenna to the diode to the amplifier, in that order. After I get the diode soldered to the base, I test the solder joint to see if it is strong. At this point, we are going to pull the LED from the ground, as I believe it's going to cause problems later, which we'll cover in another video. You can disconnect the battery too to prevent any accidental shorts or other connection issues. That'll be up to you. If you want to leave it plugged in, that's fine. So now let's talk modulation. Our diode in this circuit is going to be a radio detector or RF demodulator. RF stands for radio frequency. We won't cover the process of modulation in this video, but we will cover demodulation while looking at the waveforms of signals. There are several types of modulation, but two main ones are AM and FM. An unmodulated signal from a transmitter can be displayed like this. It's called a carrier and is uniform across its spectrum. When you modulate a signal in a transmitter, you use a mixer of some sort and superimpose the signal on the carrier, the signal meaning the audio, which would be sound or music, and you superimpose that onto the carrier. If you use FM modulation, you change the frequency of the carrier in accordance with the sound or voice doing the modulation, hence FM or frequency modulation, which is seen as a change in the carrier horizontally. With AM modulation, the sound or voice doing the modulation is seen as a vertical change in the carrier. That is, the amplitude of the carrier changes, hence AM or amplitude modulation, which can be displayed like this. Once you receive the signal, you only need part of it, the part that contains the audio information. To get that, we rectify the radio signal with the diode to get the audio information from the AM modulated RF wave or carrier, because all we need is the envelope, which is the outline of the ends of each tan vertical line, which is shown in black. Remember, the diode is a one-way device, so we lose the bottom or negative side of the signal after rectification, and we have this. Now we need to get rid of the rest of the RF signal, which is high frequency, which we don't need. Those are the tan lines, and we filter them out with what is called an RC or resistor capacitor circuit, also known as a filter, which we'll cover in detail in a later video. Now you have the envelope, which is only the low frequency sound. You now have the original sound information as pulsating DC. Incidentally, you can use the negative envelope, as some engineers prefer to do. Now, the envelope does not have to be amplified if the received signal is strong enough. You can feed it right into an earphone and hear the signal as it is a replica of the original. However, if you want to hear weak signals, you may need to feed the envelope through an amplifier, which in this case is our transistor. And that's how demodulation works. I hope you enjoyed this video and found it useful. Please like and subscribe, and check out other videos in this series and channel. Thank you for watching.